Hi everyone, I'm Jake. Today I want to share a UE widget I wrote, one of the Mars Master Material series called Mars Property Baker. This is a powerful texture baking tool. It supports mesh, landscape, and material instance. It supports the baking of material property and also layer mask. It supports the baking of Runtime Virtual Texture and also various lights including skylight. It supports the baking of textures in 2D UV space and also unwrapped by UV in 3D space. In short, Property Baker combines all kinds of baking needs. Property Baker has two versions, one without UV suffix and one with UV suffix. Please refer to the two versions listed on the screen for applicable situations. In general, the Property Baker UV version is suitable for simple texture baking based on 2D UV space. It does not support runtime virtual textures, lights, or landscape. Next, I will use this boot in the scene to talk about how to use Property Baker. It should be noted that there must be no fog-related objects in the scene where the texture will be baked. The lighting for the scene has already been baked. The lights were baked through lightmass with a lightmass importance volume added. Let's open the model's master material and take a look. The base color is connected to a bounding box based 0 to 1 UV material function. This is a property of three-dimensional space. To put it simply, it is to read the world position of the object surface represented by the current pixel point, taking the minimum bounding box point of the object as the starting value, taking the object bounding box size as the maximum value, and obtains a gradient value from 0 to 1 by linear interpolation representing the distance from the relative starting point of the object along the three directions of x, y, z. Similar to absolute world position and vertex normal node, they are all properties based on three-dimensional space. We need to use a widget that supports three-dimensional space properties to bake the texture, so we turn off the UV version of the Property Baker. Select the Mesh actor, click the Select button, and the menu in the interface is activated. Let's take a look at the Property menu first, which is currently the final shader. We can switch to any property via the menu. All bakeable properties and corresponding color spaces and channels are listed in the table on the right. Only the base color is used in the current material, so we will choose the basic color. In addition, because the scene has baked lights, we can also select the lighting property and the model is switched to a pure white material. In this mode, you can bake out only the lights. These are the parameters for three-dimensional space property. Click Unwrap Preview to see the entire model unwrapped in three-dimensional space. Let's compare it with the UV of the model, and it is indeed unwrapped based on UV. The basic principle of three-dimensional space property baking is to create a capture camera on the top of the unwrapped model in the scene and capture what the camera sees. Pay attention to the unwrap strength parameter. 0 means no unwrapping, 1 means unwrapping. Between 0 and 1 is the state between unwrapped and unwrapped. We can even make animation with this parameter. We restore the unwrapped state and close the material editor. The Unwrap Preview option can be turned off or on. We first bake the base color property. Select 2048 resolution and click Bake to Texture. The baked texture will be stored in the content root directory. When you open the texture, you will find that the color is deviated and the color space is wrong. This is a bug in UE 4.25 version. As long as you restart UE or update any parameters in the texture editor, such as turning off sRGB and then enabling it, the colors will return to normal. Now we bake the lighting property separately, select Lighting and click Bake to Texture. You can see that the light and shadow have been written into the texture. Or choose the full shader property to bake the material and lighting together. Let's take a look at the parameter Dilation UV. What does it mean? Pay attention to the UV edges. Some pixels are that are half inside the UV boundary and half outside. UE is different from 2D image editing software when baking, and there is no translucency property. Therefore, some pixels will be considered outside the UV boundary and the background color will appear, such as black, resulting in texture seams. Let's enable Dilation UV and bake the texture to compare. You can see that the new texture expands outward at the UV edge so that all pixels within the UV boundary can be filled with color using linear interpolation, which can weaken the texture seams. Let's take a look at the comparison before and after the UV boundary dilation of the texture. For the same bounding box-based 0 to 1 UVW material function, you can see obvious texture seams when Dilation UV is not enabled. And this texture has Dilation UV enabled, so it's hard to see the seams. By comparing these two textures, you can intuitively see the changes before and after dilation. This is an unfolded map obtained by manually creating a capture camera. The camera records the invert opacity information in the alpha channel when capturing. I use another widget called Texture Sample Dilator for UV dilation. Search it in the Blueprint directory and run it. Note that to use the Texture Sample Dilator, you should store the boundary information in the alpha channel when generating the image. We can capture the texture in UE like before or implement it in 2D image editing software. Find this texture and load it. Its resolution is 4096. Enable Invert Alpha to expand it outwards. You can see that the alpha of this texture contains inverted opacity information. Let's adjust the number of steps to see different results. Extrapolation can calculate the color of the extended pixel based on the color gradient of adjacent pixels. You can see a slight change in edge color after application. You can see it more clearly by reading another texture. You can see that the color changes with the direction of dilation. Let's continue. UV index can choose which UV to unwrap. We switch to the UV of index 1 and notice that part of the model normals are reversed. At this time, we need to enable the double-sided material attribute of the material instance. You can see that the double-sided material in this material instance has been enabled. Faces that previously had their normals reversed have been repaired. UV offset can control the offset of the texture in the U or V direction. When using UDIM texture, you need to use UV offset to switch between UV quadrants. Let's see how UDIM textures work. For example, this UDIM texture contains 25 UV quadrants. Because Property Baker can only bake one UV quadrant at a time, we need to offset the quadrant through UV offset. Please note that the V-direction quadrant numbers are confused here and are not in order. This is a bug in the UE 4.25 version. We load the mesh and see that the U offset value is -1 and the V offset value is 2, which means that the UV quadrant has shifted from 1001 to 1022. The 1032 shown in the scene is caused by this bug in UE 4.25. The baking area of UV offset 00 is 1001. For example, if we want to bake 1002, set U offset to -1. For example, if we want to bake the upper right quadrant of 1001, which is the 1012 quadrant, then set V offset to 1. Note that the UE displays the 1012 error as 1042. If you are interested, you can also watch the tutorial video on Texture Projector. The Buddha head model also uses UV offset when baking. Unwrap pivot controls the pivot position of the unwrapped model. The current option is gray and unselectable, indicating automatic recognition. We can enable the custom pivot option in the material instance to customize it. As for Unwrap World Size, it controls the size of the unwrapped model. By default, it is automatically calculated based on the bounding box size of the object. We can turn off the Auto option to customize. Under normal circumstances, there's no need to change the pivot and size values. Unwrap rotation is used when the mesh or landscape is rotated. If you are interested, you can read the instructions in the document on the right. So how to bake layer masks? Let's take a look at this layered material. It is a 3-layer material. Don't worry about the special effects layer below. If you are interested in this material, you can take a look at Mars Master Material. Each layer has many automatic masks to choose from, including custom mask, vertex color mask, top masks, direction mask, distance mask, elevation mask, texture curvature mask, mesh curvature mask, procedural noise mask, ARV-T mask, dimension mask. The top mask is enabled on the first layer and we use Property Baker to take a look. Turn off Unwrap Preview and restore the model to its original state. Turn off the Splat option and check the mask layer by layer. If Splat is turned on, every 3 layers will be composited into an RGB color, which is useful when baking mask textures. This is the top mask of the first layer. The second layer is the mesh curvature mask, which obtains approximate boundary information based on the model surface curvature changes. The third layer has the procedural noise mask enabled, which is a 3-dimensional noise. The automatic masks selected in this example are based on 3-dimensional space. It can be imagined that when you enable many masks with complex operations, the efficiency of real-time computing will be very low. So we need to bake these masks into textures. Click Bake to Texture. The color space of the mask texture is linear, so the sRGB option is not checked. What happens if we enable Splat? The texture to be baked will contain 3 layers of masks. The red channel is the top mask of the first layer, the green channel is the mesh curvature mask of the second layer, and the blue channel is the procedural noise mask of the third layer. Let's take a look at how to bake textures for landscape, mainly for landscape layer masks. Load in the landscape. By default, the 3-dimensional space property must be enabled for the landscape. Let's switch Unwrap Preview and Material Properties to take a look. Because there are no baked lights in the scene, the shadows disappear as the landscape unwrapped. Of course, we don't need to bake the lights for the landscape. The model on the side enables the process of baking layer masks and the operation is the same. Please note that if you are baking textures for landscape, a set of parameters called landscape resolution will appear in the interface. Generally speaking, the Property Baker will automatically obtain the value from the landscape, but if the landscape is rotated, this set of parameters will allow customization. When the Splat option is turned off, we can also bake the current layer mask to the corresponding landscape layer sample. Click Bake to Landscape Sample. Let's switch to landscape painting mode and check out the layer samples. Note that the sample uses no weight blend. In this case, we use automatic masking instead of manually drawn masks. Automatic masking does not require the UE landscape system to adjust the weights based on the sample value changes of all layers covered by each location on the landscape to ensure that the sum of the sample values is 1. We enable landscape layer debugging in the visualization. Enable different color channels for the landscape layer and you can see that the mask has been baked in. However, we found that the sampling resolution is so low. Why is this? This is because the landscape unit is 64 × 64, so the sampling resolution is only 64 × 64. We can compare the resolutions of mask maps and landscape layer sampling to see which solution is more efficient. So how to bake Runtime Virtual Textures? The scene already contains 2 Runtime Virtual Texture volumes, color and depth. We select this landscape and load it. If the Runtime Virtual Texture function in the material instance is enabled, the corresponding ARV-T workflow option in Property Baker will be automatically checked. All parameters of the 3-dimensional space property are unavailable, which means that the data is obtained from the Runtime Virtual Textures rather than from the model. At the same time, material properties marked 3D space only cannot be baked using Runtime Virtual Texture. Enable the Bake ARV-T height option to bake data from depth Runtime Virtual Texture into texture. It has only one red channel in linear color space. Next, I will introduce how to bake light and shadow into textures. In this scene, the lights have been set up and baked and the scene's build data has been generated. The light mask parameters in the world setting were also set according to the scene requirements. Finally, select the light quality in the build menu and click the build light only to complete the light baking. The data will be saved in the build data file. Note that only the default material is applied to the model to reduce material interference and shorten the material calculation process. I hope you still remember this ancient light baking process after you get used to Lumen real-time global illumination in UE5. Then, apply the material going to be baked to the model and bake it with Property Baker. This is the final result. The material and lights have been baked into the texture and the scene has no lights. Let's take a look at how to integrate the material property baking function into existing materials. This boot uses a simple complexity material from the Mars Master Material series, applying a base color, roughness, and normal texture. I want to enable a few more variations to increase the material complexity. With the imperfection option enabled, the surface of the boot shows a lot of noise. With the pearlescence option enabled, a layer of grease and pearlescent glow appear on the boot. Then enable the leaves effect option. Such a complex material requires texture baking. Open the master material and you can see that it is very complex. We need to add a material function before the final material output. Find the MFG01 Bake Property Material function, drag it into the material editor and make the connection. Note that use material attributes must be enabled in the material. Because this material is not translucent, nor does it use Runtime Virtual Texture, nor is it landscape, so keep the default settings and save the material. The Bake Property Mode option will appear in the material instance. Enable it. By default, you can use GPC, which is Global Parameters Control. Close the material editor. Run Property Baker, select the model and load it in, and you can start baking. However, animated effects cannot be baked. We can also use the RGBA Mixer widget to combine several material property textures into one Splat texture. Select the baked textures one by one and assign them to one of the RGBA channels in the RGBA Mixer interface, then select which channel in the baked texture to use in the menu and click Create Texture to complete. Or we can directly use the Bake to Existing option in Property Baker to generate the Splat map. Property Baker provides relevant help documents and scene files for you to understand. Thank you all for watching.